let's do a little bit of practice with mass percent, volume percent, and mass over volume percent. These are different ways to characterize the concentration of a solution. And we'll see this quite a lot. So let's take a common example that you might run into at the hardware store. TSP. This is a solution that people use to wash walls before they wallpaper, for example. It's a cleaning solution, TSP. And TSP is usually a 1.7% by mass sodium phosphate, Na3PO4 in water. So it's a solution, an aqueous solution, so water is the solvent, and sodium phosphate is the component. The sodium phosphate is present in water to make this solution to a concentration of 1.7%. So it's not very strong because this is quite effective. And so TSP. So let's say, let's rewrite this. Here are the different ways that a label might be written. It could be written 1.7% by mass sodium phosphate. It could also be written and mean exactly the same thing. 1.7 weight percent Na3PO4. If you saw that on a label, that makes sense. That's by mass, by weight. And another way of writing it, which you should be aware of, is 1.7%, and then we do this W over W. And again, sodium phosphate for the component. And that means that it's weight unit over weight unit to give this percent. And in fact, all of these mean exactly the same thing. And what they imply is the following. They mean that this solution has 1.7 grams of sodium phosphate in 100, because it's a percent, grams, see the weight per weight, WW weight percent by mass of solution. That's what it is. And so I use this to determine what mass of solution contains a given amount, a given mass of sodium phosphate, or I would use it to determine what mass of sodium phosphate is contained in a given amount or mass of solution. And so let's say we have an example, and let's say that here's a question. Let's say we are being asked to determine what mass of what mass of Na3PO4 is needed to be added to enough water to make, let's say, 2.5 liters of a 1.7 weight percent TSP or Na3PO4 solution. There you go. And so that's my conversion factor, and this is what I'm starting with. I start my calculation basically with the volume that I want in the end. So do you see how the question is asking for what mass of, I don't have the density of the solution. I have to make an assumption here. But the question is asking for what mass of sodium phosphate is needed given a volume of solution. So I need grams. And so I'm going to write an assumption because I'm not given anything else. Now, if I was given the density of the solution, I would use it. But since I'm not, my assumption is that I'm going to take the density of the TSP solution as being equal to 1 gram per mil. So then, my answer is 2.5 liters of solution, and I need to get that to a mass, and then I can use this. So first to mils, so a liter first to mils, so that's 1,000, and now I have mils of solution, and I need to convert that to grams of solution. And I'm taking that as 1 gram of solution is 1 mil because I'm not given the density in this question, so I make that assumption. And then I want to convert grams of solution units to a mass of sodium phosphate. Okay, so I'm not turning solution into sodium phosphate, but I'm taking these units and finding the corresponding mass of these units. So my conversion factor here is 1.7 per 100 grams. And we'll put that in the calculator. And I get 42.5 grams of Na3, PO4 required. Let's make sure I have the right number of significant figures. I need 2. 2. And that's a 5, so I'll round up by convention. 43 grams. So 43 grams is what I would put first into my container, and then I would fill it up to the 2.0 liter mark with water, and then I could slap a label on there which would be 1.7 weight % Na3PO4, and that would be my TSP. Any idea what TSP stands for? Trisodium phosphate. Trisodium phosphate. Watch. Na3 PO4. Okay, it's making a lot of noise. When I put that into water, each sodium is a plus, and I see that I have 3 of them, and each phosphate is a PO4 3 minus, which is why I need 3 of these to balance that to make a neutral salt. This is called a sodium ion, and this is called a phosphate ion, and since I need 3 of these to balance and make that neutral, this salt is called trisodium phosphate, TSP.